This is the ultimate guide to Gemini CLI, the open source AI agent from Google. By the end of this video, you'll know Gemini CLI inside out and understand how to utilize its full potential. The chapters in this video are self-contained and timestamps are below. Chapter 1: Installation and Authentication. You can install Gemini under a minute via npm. Simply write npm install-g at google/gemini-cli. Or if you're on Mac, you could also use brew install Gemini-CLI. Verify your installation by typing Gemini version in the terminal. In this case, I'm on the 0.10 version. Type in Gemini to start the CLI. Once you start Gemini, you'll see a big Gemini banner, tips for getting started, and a prompt to log in. Also, you'll notice that a .gemini folder has been created in your home directory. It contains an important configuration which we'll look at later in this video. To authenticate with Gemini CLI, there are several different options with their own pros and cons, and we'll explore the two most common ones, Gmail sign-in and an API key. In order to log in with your Gmail, simply select Login with Google. Then you'll be redirected to a sign-in with Google page and Gemini will display waiting for authentication. Choose your email address, then click sign in. After logging, you should be redirected to the authentication successful page. The Gmail sign-in comes with higher free tier usage, such as 60 requests per minute and 1000 requests per day. Although in my experience, I've been downgraded to their more cost-efficient models quite fast. Now we can test Gemini CLI and drop a message. Hi, nice to meet you. After which it responds with, "Hello, I'm ready to help. What can I do for you today?" Now let's type in the /out command to change the authentication method and see how we can set up the API key sign-in option. First, if you try to select Use Gemini API key, you'll get an error. Gemini API key environment variable not found. So let's take care of this. We press Ctrl+C twice to exit the CLI and see a stats summary of the session. Now to create a Gemini API key, we head to ai.studio/API-keys. Then we click on the Create API Key button and name your key something like Gemini CLI key. Then select Create Project from the drop-down and name your project something like Gemini CLI project. After that, click Create Project. Once the project has been created, you can go ahead and click Create Key. Once your key has been created, click Copy API Key. Then go back to your terminal and export your key as an environment variable. Export Gemini API Key, whatever your key is. Then start Gemini again, type in /out and select Use Gemini API Key, and we're done. Side note, do not share your API key. It's sensitive information and I'll delete mine after this video. We can again greet Gemini and verify that the connection has been successfully established. Quick tip, if you encounter any errors or Gemini doesn't respond for some reasons, you can show the debug console via Ctrl+O. And while the email login option comes with a higher free tier usage, the API key option comes with token caching and cost optimization. Another quick tip, you can use the /stats command to view your token usage and cached token savings. More on that later in the chapter about commands. That was all about authentication and installation. Chapter 2, Overview and Basic Usage. The simplest use of Gemini is with the -p flag, where it runs in headless mode, which means we don't even start an interactive UI. You can write Gemini -p 3 tips for better sleep, and Gemini responds after a while without the interactive UI. Headless mode is used mostly for continuous integration pipelines or scripts where no user input or manual confirmations are necessary. However, most people would like to start Gemini in interactive mode where they can interact with its user interface. To start Gemini CLI in interactive mode, simply type in Gemini in your terminal. You'll be welcomed again by a big Gemini banner, tips for getting started, and a text area for your prompt. In the footer, you'll see more information such as the directory you're in, the selected model, and if you're running Gemini CLI in a sandbox or not. Gemini CLI could be used for way more than coding, as we'll find out in later chapters. But let's have a look at a simple example first. I'll prompt Gemini to summarize the script.md file in 3 bullet points. Script.md file is the script for the chapter you're currently watching. And after a bit of work, we see that Gemini presents the summary. By the way, the @ symbol in the prompt above allows us to explicitly include context in the model, such as files, folders, and even images, which leads to more precise behavior by eliminating guesswork. Okay, moving on. By default, Gemini will use the current directory for context. If you want to include more directories, you could use the -- include directories flag. For example, here I'm including the parent directory, Gemini include directories ... The directory show command will show the current directories included in the context. As you see, our include directories flag has worked. In the next chapter, I'll share more about flags and commands. Now here's a sneak peek of a very cool functionality. Gemini CLI can generate images with Nanobanana integration. I'm going to type in the command generate a picture of water. Gemini then starts working and asks me to allow the execution of a tool from the Nanobanana MCP server. After I grant the permission, Gemini calls the Nanobanana tool, which successfully completes the call. We can now go and see that Nanobanana has generated a beautiful picture of a lake. Later in the chapter about extensions, I'm going to show you how to set all of this up. Also in chapter 6, example use cases, we're going to explore more complicated examples and usage such as coding an application from scratch, playing with the file system, and using Google search to find up-to-date information. Now let's talk about flags. Chapter 3, flags. As we've seen in the previous chapter, we can start the model in headless mode by using the -p flag and include further directories in the context with include directories flag. Now further useful flags include -m for selecting the model we want to use. For example, Gemini -m, Gemini 2.5 Flash will let the CLI use Gemini's Flash model. Checkpoints are Gemini CLI's built-in versioning and rollback system for file edits that is enabled by the checkpointing flag. When activated, it creates a snapshot of your project's state before any modifications are made, ensuring you can easily revert to a previous version if needed. Now let's see it in action. I'm going to go ahead and start Gemini with checkpointing enabled and then ask it to create a test.txt file and write inside, this is a checkpointing test. Next, I'm going to allow the file creation and run a few shell commands to make sure the file has been successfully created. Now, if we type in the restore command, we can see that the checkpoint for the test.txt file has been created. This means that if I make any changes to the file, I can always revert to its current version. And let's test this. First, I'm going to prompt Gemini to change test.txt contents and write inside, this is a second checkpointing test. And after a few seconds, we can see that Gemini has successfully updated the file, which we can verify by running the cat test.txt command. Running restore again, and we can see two checkpoints, which reflect the changes we made to the test.txt file. I'm now going to restore the first checkpoint, which will return test.txt to its initial state. Gemini confirms this by outputting restored projects to the state before the tool call, and we could also verify ourselves that this is the case by running cat test.txt again. One more thing, Gemini CLI uses the home/.gemini/settings.json files for persistent configuration, and you can also enable persistent checkpointing there by writing general checkpointing enabled true. YOLO mode. Caution with the next one. If Gemini wants to execute some commands that may be dangerous, such as creating or editing a file, executing shell scripts, it will ask for permission. To allow all future command executions or tool calls without having to grant explicit permissions every time, you can start Gemini in trusted mode with the YOLO flag by typing Gemini --YOLO. And a quick tip here, you can use the Ctrl+Y to toggle YOLO mode. Approval mode. Gemini CLI's approval mode default always asks for permission. And we've already been using it, but auto-edit is interesting. In auto-edit mode, Gemini auto-approves tools such as file editing or creation. But it does ask for permission when you want to run shell commands, for example. Another quick tip. Once you're in Gemini CLI, you can use Shift+Tab to toggle auto-edit mode. Auto-edit is less strict than default, but more strict than YOLO mode. And you can also enable YOLO mode with the approval mode flag by typing Gemini approval mode YOLO. Next up, allowed tools. If you don't want to enable YOLO mode, this flag comes in handy and lets us specify which tools Gemini CLI can run without permission. Either use as allowed tools equals shell tool, or you can also modify settings.json with tools allowed shell tool. Also, you can achieve a more granular control by passing exact tool and command you want to allow, such as run shell command git. Under GeminiCLI.com/docs/tools, you can find the exact tool names which you can use with this flag. More on tools later in the chapter about tools. Output format. With Gemini output format JSON, you can ask Gemini to output the response in a JSON. instead of human readable format. This is useful in headless mode for programmatic consumption. For example, I can write Gemini output format JSON, how are you? After which Gemini responds in a JSON format. Sandbox. The sandbox flag starts Gemini CLI in a secure environment such as Docker or Seatbelt for macOS. There are quite a lot of ways to configure the sandbox environment, and we'll talk more about it in the chapter about sandboxing. Telemetry. The telemetry flag, Gemini CLI telemetry, enables advanced usage monitoring and deeper insights into Gemini CLI. It's a bit complicated. For a simple, quick overview without the full telemetry, use the /stats command. To learn more about telemetry in Gemini CLI, check out the following link, as it goes beyond the scope of this video. To see all available flags, simply type in Gemini-help, but these were the most common ones. Chapter 4. Built-in commands. To see Gemini's built-in commands, type in /. The init command analyzes your project and initializes the Gemini Markdown file with context, which defines how the model should assist you. When present in your workspace, this file is automatically loaded and merged into Gemini's context. More on this later. As we can see, the file has been created. Similar to settings.json, the CLI uses a hierarchical system to source context from Gemini Markdown files. We have global context file, project root context, and subdirectory, which are all merged into the CLI's context. Speaking of which, you can show all the merged context from Gemini Markdown files with the memory show command. And memory list lets you list all the Gemini Markdown files that are in use. And if you create a new Gemini Markdown file or update it, you can run memory refresh to load the newest file version into the current context. With memory add, you can add shorter incremental rules to Gemini. For example, we can run memory add prefer naming React server actions with a do prefix. The command modifies the Gemini Markdown file and persists the new memory, as we can see. One of my favorite commands is the /theme command, which enables us to change the appearance of Gemini CLI. For example, I can select Dracula and note that the UI looks different now. Settings. This command provides a convenient UI for the persistent configuration of Gemini CLI. By changing the settings in the UI, we're directly modifying the settings.json file. As you see, we set the show line numbers property to true, and it's reflected in settings.json. Similarly, if we set it to false via the settings UI, then the settings.json file changes. There are 3 different settings.json locations with different scopes. System-wide settings are under etc Gemini CLI system defaults JSON, and usually we don't touch those. The 2 important scopes are user settings file under home/.gemini/settings.json and a project settings file .gemini/settings.json. In the settings UI, I can use the tab to change the focus and configure where exactly changes are applied. In the user settings, workspace settings, or system settings. The clear command will clear the screen and wipe the context from the current chat. It's like a reset for the chat. If your context is getting too long, you can run compress to instruct the model to replace the current context with a concise summary, which frees up tokens for new information. Use sparingly because the model still may summarize away important context. Copy the last result or code snippet to your clipboard with the copy command. Especially useful if Gemini responds with a long text or code snippet that is not trivial to copy with manual selection. The directory show command lists the directories included in the current context, and directory add allows us to add directories to the context. Useful if you're working on services that are spread across multiple directories. Extensions and tools lets us list extension and tools that we can install at geminicli.com/extensions. We'll talk more about them later in the video. As we've seen in the chapter about flags, restore is used to undo changes and roll back our workspace to a different version. The stats command gives us a summary of the session stats. Chat is one of the most important commands, which lets us save, resume, and manage chat conversations. For example, I can type this is chat1 and save the chat under chat_1 by typing in /chat save chat_1. Then I can say this is chat2, say hello. Gemini responds with hello there, and then I save the chat under chat_2. Next, I clear the history, list all saved chats with /chat list, and go back to chat 1 by typing in /chat resume chat_1. This is how we branch off conversations. Additionally, we can delete chats by /chat delete, and via /chat share we can export and share the current chat. Another very important command is the exclamation mark, which enables the shell mode so you can write shell commands instantly, such as ls to list all files and directories within the current folder. A bonus one, the @ symbol. It allows us to explicitly include context in the model, such as files, folders, and even images, which leads to more precise behavior from the model by eliminating ambiguity. Chapter 5. Operation Modes. We've already touched upon this in the previous chapters, but let's summarize what we know so far. There are 3 different operation modes for Gemini CLI. Headless or one-shot mode, where you can prompt Gemini and it responds without dropping you in an interactive session. This mode is activated by the -p flag. I can write something like Gemini -p generate 3 healthy daily habits, and Gemini responds immediately. This mode is useful for continuous integration pipelines or scripts where no user input or manual intervention is necessary. Interactive or default mode is the one which most people use, started by typing Gemini. Lastly, when you've started Gemini's interactive mode, you can toggle the shell mode with an exclamation mark and type in shell commands. For example, we can list all files and directories in the current workspace. You can exit shell mode by clicking escape. Chapter 6. Example use cases. Okay, let's build a few things with Gemini CLI that cover useful use cases in day-to-day workflows. The first use case would showcase Gemini's multimodal support, such as file operations and image understanding. So in the photos folder, I have 4 different photos. A photo of a mushroom, a lake, a dog, and a sunset. But they're not named meaningfully. The names are 1, 2, 3, and 4 JPEG. I'd like Gemini to rename them according to their content. So we'll start Gemini with the YOLO flag and prompt Gemini to please rename the photos inside the photos directory according to their content. Especially the poodle dog in the photo isn't very easy to recognize, so I'm curious how Gemini would be able to recognize it. And after letting its thoughts marinate for a bit, analyzing, categorizing the images, it finally renamed the files and called them dog, lake, mushroom, and sunset, which looks pretty spot on. One thing to note is that if the photos are too big, Gemini will fail because it won't be able to fit them into its context window. So you may want to compress them before that. Let's check out our photos with their new names now. And to me, it looks like Gemini did the perfect job. Now on to search tool. The second use case showcases Gemini's search tool to get up-to-date information from the internet. You remember the times when we would ask AI the most trivial question and it would respond something that is out of date because at that time AI didn't have access to the web or to search tools to fetch up-to-date information. And now Gemini has access to those tools, which makes the AI agent so much more powerful. Now we can get up-to-date information, and let's do that. I can prompt Gemini to tell me the 3 top activities that I can do in Munich today. Then Gemini starts searching the web, thinking, researching, and after a while it responds with 3 great suggestions: visiting Marienplatz, exploring Deutsches Museum, and relaxing in the English garden. And from my time in Munich, I can tell you that those are pretty amazing. Finally, let's have Gemini do what it does best, write some code for us. I'll prompt Gemini to implement a minimal recipe generator web app with Next.js and Tailwind. Gemini then starts planning and begins the implementation. After a while, as it's typical, a shell appears that needs my input. I focus the shell via Ctrl+F and confirm that it's okay to continue, so that Gemini can finish the implementation. Gemini further utilizes tools such as Google Search Tool to find a free recipe API without authentication, and a few seconds later our application is up and running. So let's check it out. The first recipe is lamb, second is Chelsea buns, and they all look delicious. Let me try to break this app by spamming the Get Random Recipe button. And then I keep spamming the button, but nothing really changes. The app looks solid. So Gemini did a pretty good job. The app didn't break after spamming this button. And last but not least, we can also follow up and ask Gemini to explain the architecture of the applications, which is actually really useful, which is something that happens very often in our jobs. When you want to work on some microservices from some other team, you can go in there, ask Gemini to explain the architecture, and you get to ramp up really quickly. So Gemini analyzes the code and responds with a very detailed summary. However, I don't have that much time, so I prompt Gemini to give me a shorter summary. And as we're used to from Gemini, it delivers again. So those were 4 useful use cases for Gemini that developers use in their day-to-day workflows. And I think all the people would start using them because code is becoming so much more accessible. Chapter 7. Custom commands. We're going to learn how to automate our best prompts as reusable custom commands. Custom commands are really powerful as they support arguments, shell, and file injections, as we'll see very soon. Custom commands are essential to every developer's workflow. Similar to settings.json and Gemini Markdown, custom commands use hierarchical structure. User commands are saved in home/Gemini/commands, and project commands are saved under project/Gemini/commands. The name of a command is determined by its file path relative to its commands directory. Sounds very confusing, but let's have a look at an example and it will become more clear. So a file at home/Gemini/commands/test.tom becomes the command/test. And a file under project/Gemini/commands/git/commit.tom becomes the namespace command git column commit. So pretty much whatever the name after /commands is, that's the name of the command. If we have two names after /command, then it becomes a namespace command, and then we separate it with a column like git column commit. Okay, let's have a look at our first command now and utilize the arguments injection right away. I have the application running and would like to change the get random recipe button from blue to orange. So let's create a bug fix command that we can run whenever there is an issue that we want to fix. Custom command use the TOML file format. So under home/Gemini/commands, we'll create a bugfix.toml file with the following description and a prompt. The description is just metadata for us and prompt is what the model receives. So the description could be generates a fix for a given issue, and the prompt is please provide a code fix for the issue described here, and then we have curly braces and arguments. Curly braces with arguments is a placeholder where we would inject the arguments of the bug fix command, and I'll show you now how it's done so it becomes a bit more clear. So we can use a command like /bugfix, fix scrolling on homepage. And fix scrolling on homepage are the arguments that will be injected into the prompt. What Gemini will receive is the prompt that we have defined and replace the arguments placeholder with the value that we have passed to the bugfix command. The final command will be here on the screen. Let's see it in action. I've started Gemini in YOLO mode and then executed the command /bugfix. Get random recipe button should be orange. And after about 20 seconds, Gemini has applied the fix that we have asked for. The button is now orange. Now it gets even better, although a bit more confusing in the beginning, but I'll explain. We can not only inject arguments into the custom commands, but also shell executables, which makes those custom commands extremely powerful. So let's consider the following command, commits column message. The command generates commit message from the staged changes. Let's have a look at the prompt. Please generate a conventional commit message based on the following git diff, and then between exclamation mark and curly braces, we inject the result of the shell command git diff staged. This way, Gemini receives the staged diff into the prompt and can generate the appropriate commit message for us. We can start Gemini and try it out on a newly set up Next.js project, which is a recipe generator. So let's type in /commit message. And this is very important. Gemini asks for permission to execute the git diff staged shell command within our prompt. So it asks for permission whenever there is a shell command. We allow this, and then Gemini proceeds to create the following commit message. Feature recipe. Implement random recipe generator, and then also accompanies it with great description. So our custom command works perfectly. We don't need to think about commit messages anymore. We can just have this custom command and have Gemini generate great commit messages for us. Last but not least, we can inject file contents into the custom commands. Let's look at an example how this is useful. Consider the following review TOML command. The description is reviews the provided context using a best practices guide. And the prompt that Gemini will receive is, you are an expert code reviewer. Your task is to review the args, and those would be injected as we have seen before. But now for the new part, use the following best practices. Add curly braces, docs best practices markdown curly braces. So note the notation with add curly braces surrounding best practices markdown file. This notation signals to Gemini to embed best practices markdown file content directly into the prompt. So we can write a best practices file and then inject it into every single custom command. Then we use the command via /review source app page tsx, for example, and Gemini will inject its best practices markdown file content directly into the prompt and generate a lengthy review for our page TSX file, mentioning that, for example, error handling is missing, and point out a few other issues such as reusability and type safety. This was all about custom commands, where we have learned what they are, how to create them, and how to inject arguments, shell commands, and file contents directly into the custom commands so we can make them much more powerful. Chapter 8, Customization and Context with Gemini Markdown. In this chapter, we'll learn how to use the Gemini Markdown file to provide persistent instructions to Gemini CLI. And at the end, I've saved a very neat hack with the Gemini Markdown files for you. So Gemini Markdown defines how the model should interpret our project, what technologies we use, which conventions to follow, and what guidelines it should apply when assisting. When present in the workspace, this file is automatically loaded and merged into Gemini's context. I recommend creating your initial Gemini Markdown file by typing the /init command. Let's run the init command in our recipe generator project. Gemini CLI will scan your repository and generate a Gemini Markdown file at the project root. The generated file contains example sections. You can edit to fit your needs. And memory list will show all the Gemini Markdown files that are used as part of the AI agent's context. And memory show prints the AI agent's context that is generated by the Gemini Markdown files. This way we can inspect the file that we just generated by running the init command. It has different sections such as project overview, building and running, installation, and so on, like you get the idea. By running memory add, we can then add additional instructions as we please. For example, we can say use pure functions whenever possible. Then allow Gemini to save the memory, and if we have a look at the user's Gemini Markdown file in our home directory, we'll notice that the memory has been appended to the file. And although Gemini Markdown is the default file name, we can configure those in settings.json as shown. In this case, agents, context, and Gemini are all valid to provide persistent context to Gemini. Additionally, we can break down large Gemini Markdown files into smaller components by importing content from other files using the @/file markdown syntax as shown. We're almost there to show you the hack, but let's have a look at hierarchy first. Similar to settings.json, Gemini CLI reads Gemini Markdown files hierarchically. First, it reads the current working directory, then any parent directories, then user level configuration under home/Gemini/Gemini Markdown. And project-specific files override higher level ones. This allows global defaults at user level while keeping detailed configuration in each project. So the hack I want to show you is the mode-specific configurations. Phil Smith has shared some great Gemini Markdown files for explain mode and for plan mode. As you can see from the name, explain mode instructs the model to help users understand complex code bases and so on, while plan mode is used for different purposes, such as to instruct the model to research, analyze, and create implementation plans. Now I would like to run two instances of Gemini, one in explain mode and one in plan mode. For this, I'll create two subfolders in my project, Gemini Plan and Gemini Explain. We'll go ahead, copy the explain instructions, create a Gemini Markdown file, and paste them there. We'll then do the same thing for the Gemini Plan folder. Copy the plan mode instructions and paste them there. Then we can start one instance in plan mode by running Gemini in the Gemini Plan directory. And by using include directories flag, we can make sure that the root of the project is also included in the context. And by inspecting the memory, we can see that Gemini is in plan mode. We can additionally confirm this by asking the model which mode it is in, and it answers I'm in plan mode. So meanwhile, I can start a second instance of explain mode in the other terminal and have two Gemini instances running in different modes according to my instructions. Chapter 9, Tools. Tools extend Gemini's capabilities beyond text generation. They allow it to read and write files, execute shell commands, fetch URLs, and perform other controlled actions. In this chapter, we'll go through the tools system in Gemini CLI. We've already touched on a lot of tools concepts in this video, but this chapter puts them all together. Some of the more common tools are file system tools that read and write local files, shell tool that runs shell commands, and a web tool that fetches and parses web content, and a search tool that uses Google search to find up-to-date relevant information. By default, Gemini asks for permission before executing tools, such as writing to a file or executing shell scripts, as you can see on the screen. To allow each tool execution without user approval, run Gemini in YOLO mode. Gemini-YOLO. You can toggle YOLO on and off with Ctrl+Y, and if you want to instead a tuned down approval mode, run Gemini with approval mode Auto Edit. This mode auto approves file edits, but still requires confirmation for shell commands. You can also enable fine-grained approval control by running Gemini allow tools shell tool or modify settings JSON with tools allowed shell tool. An even more granular control is achieved by passing exact tool and command you want to allow, such as run shell command git. By the way, I also recommend enabling the newly shipped to-do tool in your .gemini/settings file by writing use write to-dos true, which allows the Gemini agent to create and manage a list of subtasks for complex user requests. Let me show you how it works. I have implemented a recipe generator app to generate random recipes. Now I will ask Gemini to extend the recipe generator with the ability to create recipes and use the to-dos tool. Usually it's not necessary to explicitly ask to use the to-do tool, but I wanted to make sure that Gemini definitely uses the tool so I can demo it. As we can see, Gemini has created 4 to-dos and starts working on each task that is initially marked as pending. Now the first task is marked in progress and Gemini keeps going. Reads files, creates files, modifies the code, tracks and displays progress as it completes all to-dos one by one until it finishes the task. We can now check the final result of our application and create a simple recipe. Well, to be honest, it doesn't look great, but not terrible either. And final tip, running the /stats command will give you an overview of which tools were invoked during the session, among other details. And in the chapter about MCP and extensions, we'll learn how to extend Gemini with more tools such as Nanobanana or GitHub. Chapter 10. Sandboxing. In this chapter, we'll cover sandboxing, a mechanism within Gemini CLI that isolates file system, shell, and network operations. It is especially useful when you allow automated or semi-automated actions, for example via YOLO or custom commands, and you would like to limit the risk as well. You can enable sandboxing using 3 methods. The first is via the command line flag -s. Simply type in Gemini -s and it will run in a sandbox. As you can see, the terminal displays using macOS seatbelt. And also the footer says macOS seatbelt. The second way to enable sandboxing is via the environment variable flag. Simply export Gemini sandbox true and then test again by running Gemini. This time there is no need for the -s flag because we've set the environment variable. And the third and final way to set sandboxing is if you modify the configuration at home/Gemini/settings.json or in project/Gemini/settings.json by writing tools sandbox true or Docker if you prefer. As we've already said, on macOS the default sandbox uses seatbelt framework, but on Linux or Windows, sandboxing is typically backed by a container engine such as Docker. On macOS you can set a seatbelt profile via seatbelt profile environment variable, and the supported profiles include permissive open, permissive closed, permissive proxied, and you can see the rest of seatbelt profiles and refer to them on the screen. Chapter 11. Extensions. In this chapter, we'll do something very cool. We'll connect Gemini CLI with the Nanobanana and GitHub MCP servers with the power of Gemini extensions. And I was quite surprised how easy and smooth this whole integration is. Let me show you. If you go to GeminiCLI.com/extensions, you can see a list of extensions that you can install into your Gemini CLI. Let's start with the Nanobanana one so we can add the capability to Gemini CLI to generate photos. First, we'll find the Nanobanana extensions on GeminiCLI.com/extensions and follow the link to its GitHub page. On the GitHub page, we scroll down and copy the installation command and run it in our terminal. By listing the directories in .gemini/extensions, we confirm that Nanobanana has been installed. And we're almost done. The only thing remaining is to now set up an API key for Nanobanana. For this, we'll head to ai.studio/API-keys and create a new API key by clicking Create the API Key button. Since I've already done this, I'll copy my existing key, go back to the terminal and export Nanobanana Gemini API key and paste my key there. Now, in order to use this API key with Nanobanana, we need to set up billing, which can be done in like 20 seconds. Go back to ai.studio/api-keys and click Setup Billing. You'll be redirected to a page where you can click on Manage Billing Accounts, create a new account, and follow the instructions. And we're almost there. Next, we click on Setup Billing again, and this time choose Link a Billing Account. Then we select the billing account that we've just created. We refresh the API keys page and notice that the billing has been set up. Now let's test our Nanobanana extension and generate an image via Gemini CLI. We start Gemini and note that there is one MCP server connected, which is the Nanobanana server. And if you write /MCP list, you can see the list of all connected MCP servers and their names. Now we type in /generate a picture of water, then Gemini wants to connect to the Nanobanana MCP server and call generate image tool. We allow the action, and after a couple of seconds, our image has been generated. Finally, we can go back to cursor to check out the output, and the picture looks pretty great. With this, our Nanobanana integration is complete. In the CLI, you can type in /extensions list to view all available extensions. Finally, I'd like to showcase how to integrate Gemini CLI with the GitHub's MCP server, so you can manage repositories, issues, pull requests directly from Gemini. Again, we go to geminicli.com/extensions and follow the GitHub's extension link. Once there, we scroll down to Google Gemini CLI and open the link. Then we copy the Gemini install command and paste it in our terminal. After successful installation, we verify again that a GitHub folder has been created under .gemini/extensions and the folder is there. Now let's quickly set up the free API key here again and see the extension in action. We go back to the Google Gemini CLI GitHub page and follow the GitHub personal access token link. Then we click Tokens Classic tab, select Generate New Token Classic from the drop-down, name our token and scope it to the repo access, as it should be enough for our purposes. Make sure you never share your API key, and I'll delete mine after this video. Next, we copy the MCP server configuration and paste it into home/.gemini/settings.json, which will configure access to GitHub. Then we copy the token we've just generated and replace the placeholder for authorization with our token, and then we save the file. Let's start Gemini now and type in the /MCP list to confirm we're good to go. We can see a summary of the MCP servers we have installed along with the actions they provide, and GitHub is there. Now we'll go to GitHub, create a milestone manually, and then ask Gemini to create an issue within this milestone. I type in create a test issue 2 in milestone Gemini CLI test milestone. In the AI Assistant rep, Gemini asks back who the owner of the repo is and the ID of the milestone, which we can find on the milestone link in GitHub. I respond accordingly and the action has been successful. We go back to GitHub and refresh the page to verify. We chose the newly created test issue 2 in milestone 2. Additionally, we can list our repositories, create PRs, and way more with this GitHub MCP server. Chapter 12, IDE Integration. In this chapter, we'll explore how to integrate Gemini CLI into your IDE, such as Visual Studio Code or Cursor, so that you can work more smoothly between your editor and Gemini CLI. When integrated with your IDE, Gemini CLI automatically gains context to provide more relevant and accurate responses. This context includes the 10 most recently accessed files in your workspace, your active cursor position, and any text you have selected. I'll be using Cursor here, but Visual Studio Code works the same way. First, let's open Cursor and go to Extensions. In the search bar, type in Gemini CLI, then select the Gemini CLI Companion extension and click Install. Then I'll open a new terminal and move it to the right side so you can see better. I start Gemini and the CLI immediately prompts me if I want to connect Cursor to Gemini. I click yes and continue. Next, I log in quickly with Google, then I write /ID status to see if the connection has been established. Seems like it hasn't yet, so I follow up with /ID enable, which completes the integration. At this point, I've also run the /ID install command, but this wasn't necessary since I've already installed the extension manually. The connection stays active for subsequent usage. For example, if I close Cursor, then open it again and type in Gemini in a new terminal, the /ID status command says that Gemini is connected to Cursor. As we have already mentioned, the integration between the IDE and CLI makes Gemini responses more accurate due to the additional context gained. But let's see what else the integration brings. Namely, if I ask Gemini to please add better error handling to app source page TSX, then we notice that the edits that the AI agent did appear in our IDE as well. Additionally, we can accept, reject, and preview changes directly from our editor. In this case, I'll approve the change from the editor UI, which propagates to Gemini, and our AI agent keeps working. So that's how you integrate Cursor or Visual Studio Code with Gemini CLI. Chapter 13. Gemini CLI, Architecture and Interaction Flow. In this chapter, we'll walk through the Gemini CLI's architecture, understand how it is structured internally, and what happens behind the scenes when you press enter. We'll cover its core components, the interaction flow between them, and the key design principles that make it modular, extensible, and safe to use. Gemini CLI is built from two main packages and a set of tools that extend its capabilities. The CLI package. This is the user-facing layer. It handles reading and parsing user input, managing conversation history, rendering responses and UI themes, and presenting the final output. Think of this layer as the front end of Gemini CLI, responsible for user experience and display. Secondly, the core package. This is the backend of Gemini CLI. It receives requests from the CLI package and handles all the communication with the Gemini API. Its main responsibilities are building prompts, including history, Gemini Markdown files, and memory context, managing sessions and conversation state, also registering and executing tools, and orchestrating the flow. The core package acts as the bridge between your terminal and the Gemini API. Now let's talk about tools. Tools are modular components that extend the model's capabilities. For example, file tool to read and write local files, shell tool to execute shell commands, or web search tool. Now that we've covered the architecture, let's have a look at the interaction flow. A typical Gemini CLI request follows this sequence. The user input goes to the CLI package. You type a prompt or command in the terminal. The CLI package parses the input and sends it to the core package. The core package receives the input and constructs a complete prompt for the Gemini API. This may include your prompt text, conversation history, available tool definitions, and project context from Gemini Markdown files and memory. The core then sends this constructed request to the Gemini API endpoint. Then the Gemini API processes the prompt and returns either a direct answer or a request to use a tool. For example, read a file, run a shell command, or fetch web data. When the Gemini API requests a tool, the core package prepares to execute it. If the operation can modify the file system or run shell commands, the CLI displays the tool name, its arguments, and requests confirmation. Read-only actions such as reading files or fetching URLs may execute automatically. After approval, the tool runs inside the configured sandbox. The result then is returned to Gemini API for further processing. The Gemini API processes the tool output and generates a final response, often combining model reasoning with the data retrieved by the tool. The core package receives the response and sends the final structured response back to the CLI package. The CLI renders the result in the terminal showing formatted text, code blocks, or file diffs. And if checkpointing is enabled, the operation is locked with a snapshot for potential rollback. Three key design principles include modularity. The CLI or the front end and the core or the back end are separate. Then we have extensibility. The tool system is modular. New tools can be added without changing the core. And then thirdly, user experience. The CLI is designed for rich interactive use. Clear approval prompts, structured output, themes, and checkpoint visibility. This was all from me. This was the ultimate Gemini CLI guide. I hope you enjoyed it. I hope you learned something, and thanks a lot for watching.